So the next distribution we want to talk about is the geometry distribution. It is based on Bernoulli trials, but in a different way. So in binomial distribution, we talk about n independent Bernoulli trials and identically distributed. So suppose in the binomial one, we define number of success out of n trials. So let's say we want to define new random variable x, which is defined as number of failures before the first success. So x is number of failure before the first success. Now again, these are Bernoulli trials. These are repeated, identical, independent Bernoulli trials. Okay. In the binomial setting, we have like a finite number of trials, but in this case, it's not going to be finite; it's countable infinite. So x can be number of failures before success. It can be 0, 1, 2, all the way up to infinity. So this one is countable infinite, discrete random variable. This is the first one we encounter like that. Bernoulli one is finite. It's a discrete random variable, but finite. And then the binomial one also discrete and finite. But this one is countable infinite. I mean, it can take, its support is going to be 0 to infinity. So the probability mass function is going to be look like this. So if I draw a table, you can see the random variable x. So 0 failures. That means the first trial it was success. And this means success after first trial. So the first one is success. I mean, the first one is a failure. Then the second one was success. Okay. So remember the definition. This is the number of failures before the first success. Okay. So this means so number of failures. So this is number of failures are 0. Okay. That's going to be 0. Number of failures 1. The number of failures 2. That means first 2 trials were failures, and the third one becomes success. So forth. Okay. So you can generalize this. You can see that probability x equal k is going to be basically first k trials going to be failures, then the next one is going to be success. So we denote this distribution using, sometimes you will see this kind of writing. So this is success probability for single Bernoulli trial. So if remember that in binomial, we wrote it as x1 plus of xn. Okay. If you try to do this, this is going to be x1. I mean, let me write it this way. Okay, so it's up to infinity. Okay, so now we can calculate the expected value. So before that, let me write the CDF. With the binomial, we don't have nice formula, but with the geometry distribution, we have nice formula for CDF. So what's the CDF? Probability x less than or equal little x. That's going to be 1 minus probability x more than x. And then you can prove that it's going to be same as with some calculation. I will leave it that. If not, if you cannot find it, let me know. post in the discussion board so we can discuss. So it's going to be 1 minus px plus 1, which is useful when we do the problems. Okay. So for example, if you want to find probability x less than 3, so that's going to be 1 minus p to the 4. Okay. So this is the CDO. What is this? This is probability x less than or equal to 3. That means the number of failures at most 3. So next one, we can talk about the expert value. One method would be using the moment generated function. So I can write the moment generated function. So that's going to be e to the t x, and the probability. If I use the formula. Okay. So this one is going from x equal 0 to infinity. So again, we can do the same kind of trick we did last time. I can bring 1 minus p here, then put e to the t here, and then the entire thing to the x. And then I can bring p to the outside. So then this is basically geometric series, and we know that that sum is going to be 1 over 1 minus p to the et, provided that term is absolute value of that term is less than 1. Okay. Of course, this is positive term, so you can just write. And that means basically t should be less than negative log 1 minus p. P is less than 1, so this term is going to be positive but less than 1. So it's going to be some negative number, and then this one becomes positive. Remember the log curve. So somewhere here it's negative, but then you multiply by negative term, this becomes positive. So this is the homogeneous function. So let me write it again. Is p over 1 minus p to negative. And you can differentiate and evaluate at 0, and you can show that the first moment is going to be, once you differentiate and evaluate at 0, it's going to be 1 minus p over p, or you can write q over p, which I use here. Okay. And then using the second, you can do this another differentiation and find the second moment, and then get the variance. So the variance is going to be 1 minus p over p square. So this is 1 minus p over p. Another property which I want to discuss here is the memoryless property. I didn't mention that, but the geometry distribution got memoryless property. So what is that? That means, let me write here. So for example, if you try to calculate probability x more than or equal x plus y, given that x is more than x. So you have the condition, you have this extra information. But memoryless property says knowing that's not going to help you. It's same as not knowing that. So you can prove that if x is a geometry, then this is true. So it's called as a memoryless property. So geometry and the variables. I mean, it's a simple proof. You can let me maybe give the first one. So that's basically probability x more than or equal to plus y. Remember, this is probability A given B is probability A and B over probability B. So You can write this, and then substitute your formulas. Basically, you have the CDF. So here we wrote the CDF. Using that, you can substitute there and then get the answer. So if this is CDF, so what is a CDF? CDF is 1 minus p to the x plus 1. So that means the while function is going to be 1 minus p to the x plus 1. So you can substitute that in here. This is going to be 1 minus p to the x plus y plus 1. 1 minus p to the x plus 1, which is going to be which is going to be the 1 minus p to the y. Okay. So so this would prove that more or less property. Okay, so here you can find few examples. Try do those. Again, if you are not sure how to do it, please post in our discussion board, which is very live, and everyone need to participate in there. So please use the discussion board to discuss problems.